Hello everyone. In this video, we will discuss about the introduction to the relay. Also, we will discuss some relay technology, relay functions. So let us have a look on the contents of this video. So in this video, we will see relay technology, relay functions, some important functions of the relay. Then we will discuss about the relay classification. So we will have a look on some different types of the relays also. So actually the relay was invented more than 160 years ago, and during the last 50 years this relay has undergone considerable changes, and the most obvious and important change is the reduction in the size of the relay. So using new and advanced contact materials, the switching capacity has either been maintained or increased, and the use of new plastic materials that has improved the insulation property of the relay. State of the art technology and precision engineering that has led to increased relay sensitivity. So relay sensitivity means the ratio of input coil power to switching capacity. So typical applications of the relays are, we can say, in case of laboratory instruments, telecommunication systems, computer interfaces, domestic appliances, air conditioning and heating systems, automotive electrics, traffic control, lighting control, building control, electric power control, business machines, control of motors and solenoids, tooling machines, production and test equipment, etc. So these are the various applications of the relays. So here in the graph, how relay innovation is developed, that is shown here with the help of graph. So relays, these are generally electromagnetically operated switches. So actuating quantity may be current or voltage. If assuming the actuating quantity as a current, so this current on a coil operates one or more galvanically separated contacts or load circuits. The electromechanical relay that can be controlled remotely, and that can be used as a switch which is capable of switching multiple circuits either individually or simultaneously, or sometimes in sequence also. So with the help of relay we can use means that switch can be used individually also, for simultaneous operations also, and for the sequence operations also. So primary functions of the relays are say first is the galvanic separation of the primary or actuating circuit and the load circuits. Then single input multiple output capability can be obtained with the help of relays. Separation of different load circuits for multiple relays that can be observed. Separation of AC and DC circuits. Interface between electronic and power circuits. Multiple switching operations or functions, for example delay or signal conditioning, etc. Then amplifier function. So these are some important functions of the relay which can perform in our electrical engineering field. So now let us have the look on the classification of the relay. Now these relays have the same subsystems and principles of operation regardless of whether they are electromechanical or electronic, or designed to switch signal or high power loads. So these basic principal functions are: first one is the conversion of an electrical input signal on the primary side to an intermediate and non-electric physical signal. Second principal function is reconversion of this non-electric physical signal to operate a switching element which is on secondary side, such as contacts which switch and conduct electric current, that is for output circuit or for load. And the use of non-electric signal between primary and secondary side provides the necessary galvanic separation or isolation between input and output circuits. So all that things are shown here in this diagram. So this is the primary side, this is the input, here is the control element on secondary side, here is the switching element, this is the output, and these both primary and secondary side are isolated from each other. So these basic relay functions that can be achieved in very different ways. The resulting variety of designs that can be classified in several groups. So means electromechanical relays, electronic relays, again that can be classified in different ways. So according to the nature of secondary switching element, basic relay types are, first one is the electromechanical relay. So in this case of electromechanical relays, the switching element is a mechanical contact. The switching element is the mechanical contact. This is the most widely used type of relay design. Standard yoke type designs as well as reed relays and others are part of this group. The principal internal functions of the electromechanical relays are conversion of electrical current to a magnetic field, then conversion of the magnetic field into a mechanical force, and the force operates the contact which are on the secondary side. So this contact switch and conduct electrical current to the output circuit or to the load. So again electronic relays are also there. So this type of relays uses electronic switches such as transistors, triacs, etc. as the main switching elements. So relays can also be classified according to the nature of the intermediate signal between the primary side and the switching element. So for example, electromagnetic relays. So in these relays, a magnetic field generated by the input signal operates on the mechanical contacts. An example of this electromagnetic relays are the standard yoke type relay or the reed relay. Then optocouplers are also there. So in this type of relay, the electronic switching element is controlled optically. On the primary side, an optical signal is transmitted by means of a light emitting diode, while phototransistor acts as a receiver and controls the switching element. So in this case, the optical connection provides the galvanic separation. Then thermoelectric relays are also there. In these relays, the input energy on the primary side hits a bimetallic part which actuates the contacts mechanically. Piezo relays are also there. In these relays, the contacts are operated mechanically by the piezoelectric effect. Signal relays are also there, power relays are also there, contactors are also there. So the difference between these signal relays, power relays and contactors, their application areas is shown here in one diagram. So if we see the graph of voltage versus switching current, then we can see the application area of all these signal relay, power relays and contactors. So if these actuating quantities are more, then For lower quantities, we can go for the signal relay. For intermediate quantity, we can go for the power relay, and for high quantity, we can go for the contactor. So, let us discuss about this signal relays. So, signal switching relays that cover signal, data, and voice switching applications up to approximately 2 ampere resistive load. So, typical applications are measurement systems, computer interfaces, and telecommunications. Designs for signal relays include standard yoke type relays, reed relays, and solid state relays. Then power relays. So according to IEC standard 255, these are the relays which switch up to 600 volt and 100 ampere. Up to 600 volt and 100 ampere. The high current area overlaps the switching range of the contactors. You can see. So generally, power relays switch up to 16 ampere for printed circuit board types and up to 30 ampere for industrial types. The most common design for power relays is the standard yoke type relay. For some applications, solid state power relays may be used. Then contactors. So although contactors are not strictly relays, they have the same design principles. Like relays, they are remote controlled switches. The difference is the considerably higher input power consumption, higher switching capacity, and larger size. Then power relay types can be also divided according to their mechanical features. That is miniature, PCB, and industrial relays. So the term miniature refers to physical size. However, as the relay technology has used this term for some time, it does not necessarily give an indication of absolute size. Printed circuit power relays are designed for mounting on the PCBs, that is printed circuit boards. Then industrial relays are typically used in switching cabinets by control panel builders. So here, as you can see, there is wide range of different electromechanical relays to suit almost all applications. So having such a large choice, that will make the selection difficult naturally. So design principles throughout the different relay classifications are the same, and basic characteristics and technological aspects are interchangeable. So while selecting the relay for any particular application, we have to study the different type of the relays, and accordingly we have to select the which relay is most suitable for our particular application. So different parameters, different design criteria, applications, systems, circuit, equipment, that we have to consider while selecting the relays. So thanks for watching. Thank you.